Alright guys, as what I mentioned in the first lesson, there are so many carbon compounds that we need to know in SPM. Yeah, there are so many carbon compounds that we need to learn in SPM. So to make it a bit easy for the learning process, we need to do some grouping. Yeah, we need to group the carbon compounds together. Yeah, to make it a little bit easy for us to learn. So there are total 6 different groups of carbon compound, but we don't call it a group, we call it as homologous series. So we have 6 homologous series for the carbon compound, which is alkane, alkene, alkyne, alcohol, carboxylic acid, and ester. Yeah, so do remember all the homologous series, they are decided by the functional group. Okay, by looking at the functional group, the sex organ, then we know exactly, okay, that substance is an alkane, alcohol, ester, alkene, or what. Yeah, we need to look at the functional group. Okay, so in the previous lessons, okay, in the last few lessons, we already learned alkanes. We already covered the concept of alkane. So we covered and we learned everything for alkanes already. Yeah. So now we will go on with the next homologous series. Okay, we will start with another new homologous series. Okay, so we will learn alkene. So in this lesson, we will learn and we will cover the concept of alkene. Okay, so let us start with our lesson today. Okay, so as what I say, we are learning about alkene in this lesson. So we need to know what is the functional group of alkene. So how you know the chemical substance actually is an alkene. So the functional group, I always love to call it as sex organ. So when you look at the sex organ, you know exactly that guy, that fella is a man or woman. Okay, it's a boy or it's a girl if you look at the sex organ. So functional group is the sex organ for carbon compound. So if you look at the functional group, then you know already that substance is an alkene, that substance is an alcohol, that substance is a carboxylic acid, and so on. Yeah, so the functional group for alkene is carbon carbon double bond. Okay, carbon carbon double bond. So when you given a picture like this, okay, when you given a picture, and on the picture, if you can see there is a carbon carbon double bond, then you know already this compound is an alkene. Okay, any compound that contain carbon carbon double bond is actually an alkene. Yeah, so make sure when you answer the question, if the question asks what is the functional group of alkene, many students only write, okay, when the question asks what is the functional group, okay, when the question asks what is the functional group for alkene, so many students, they only write double bond. Okay, many students only write double bond. So if you write double bond, you get 0, no mark at all. Yeah, so you need to mention it is carbon carbon double bond. You can put the carbon in front here, or you can mention it's double bond between carbon atoms. Okay, you have double bond between carbon atom. So now at least we know this is carbon atom, this is carbon atom, there is a double bond here. Because if you only put the word double bond, there are so many possibility. Okay, double bond can be between other substance. For example, carbon and nitrogen can have a double bond. For example, carbon and oxygen has a double bond. So if you only say double bond, the examiner don't understand the double bond is between carbon and nitrogen, or carbon and oxygen, or carbon and carbon. So you need to specify. Yeah, you need to tell the examiner, okay, the double bond is between carbon atom. Okay, so I repeat one more time. In SPM, if the question asks you what is the functional group, okay, if the question asks what is the functional group, okay, of alkene, what is the functional group of alkene? So if the question asks what is the functional group of alkene, you can draw it out like this. You can draw a carbon carbon two lines, carbon-carbon double bond, you can draw it out, or you can write carbon-carbon double bond. Okay, you can write carbon-carbon double bond, or you can write double bond between carbon atoms. Okay, double bond between carbon atoms. Okay, so this is how you answer the question if they ask you what is the functional group of alkene. Yeah. Okay, so now the second thing that we need to know is the general formula. Yeah, so general formula is used to predict the formula for all the alkenes. So if we want to know the formula of alkene, we will use CnH2n to predict. Okay, we will use CnH2n to predict, yeah, the formula for all the alkenes. So we don't need to memorize the formula of alkene. All the formula can be predicted. Yeah, so do remember, for alkene you have to be very careful, because for alkene the N must start from number 2. The N must start from number 2. Okay, you cannot substitute N equal to 1 for alkene. Cannot. Alkene, the N must start from number 2, then go with number 3, number 4, and so on. Yeah, so why for alkene the N must start from number 2? Because alkene, the functional group is carbon-carbon double bond. If you substitute N equal to 1, you will get CH2. If there is only one carbon, if you only have one carbon, there is no way you can have a carbon-carbon double bond. To form a carbon-carbon double bond, we need minimum 2 carbon. Okay, we need minimum 2 carbon in order to get carbon-carbon double bond. So in order to get minimum 2 carbon, so the N must starting with 2. The N must start from 2. Okay, so please be very careful. Alkene, the N must start from 2. Alkane, the N can start from number 1. For alkane, the general formula is CnH2n plus 2. For alkene, the general formula is CnH2n. Yeah, so for alkane, the N is okay to start from number 1. Okay, alkane, you can start the N from number 1 and so on. For alkene, the N must start from number 2. Okay, alkene, the N must start from 2 and so on. Yeah, so this is something that you have to be very, very careful. Okay, so now let's continue a little bit more. Let us continue a little bit more. So let's say, okay, this is one example that we will do together. So now I want to get the formula for alkene, which has 3 carbon. Okay, I want to get the formula for alkene. The alkene must have 3 carbons. So to predict the formula for alkene, we will use CnH2n. CnH2n is the general formula that we use to predict the formula for all our alkene. So we are looking for 3 carbon. So to get 3 carbon, substitute N equal to 3. So if you substitute N equal to 3 into the formula, you will get C3H6. Okay, you will get C3H6. So C3H6 is the formula of alkene that we want. Yeah, so this is how it works. Okay, all right. So the next thing, all right, you need to understand that. Okay, you need to understand that. Okay, alkene. Okay, so for alkene here, all right, for alkene, you need to understand that alkene, we also can call it as unsaturated hydrocarbon. Yeah, we can call alkene as unsaturated hydrocarbon. Why? Why we can call alkene as unsaturated hydrocarbon? Okay, so the word unsaturated is because of what? Unsaturated means that you have double bond or triple bond. Okay, the word unsaturated means you have double bond or triple bond. Okay, saturated means you only have single bond. So alkene, we have double bond. Alkene, we have carbon-carbon double bond. That's why it is unsaturated. So why we can call it as hydrocarbon as well? Because alkene is made of carbon and hydrogen only. Alkene is made of carbon and hydrogen only. That's why alkene, we can call it as hydrocarbon. Okay, so that is what you need to know. So remember, in SPM, whenever you see the word saturated hydrocarbon, they are referred to alkane. When you see the word saturated hydrocarbon, they are referred to alkane. Why? Because the word saturated stands for single bond. Alkane, the functional group is carbon-carbon single bond. So alkane has single bond. That's why alkane, it is saturated. Okay, so when you see the word saturated hydrocarbon, so you know they are referred to alkane. So when you see unsaturated hydrocarbon, so there are two possibilities. Okay, when you see unsaturated hydrocarbon, it can be alkene that we learned today, and it can be alkyne that we will learn in the next subtopic. Yeah. So alkene has carbon-carbon double bond. Alkyne has carbon-carbon triple bond. So remember, when you have double bond or triple bond, it is unsaturated. When you have single bond, it is saturated. So you have to be careful. Okay, so we can call alkene as unsaturated hydrocarbon is because alkene contain double bond. Double bond is unsaturated, and alkene is made of carbon and hydrogen only. That's why we call it as hydrocarbon. Okay, so now, okay, this is one of the way they can ask the question. Okay, I give you a sample question here. So this is one of the sample question that we will do together. Okay, all right. So now, okay, we will try to do this together. Okay, so the question is this: which of the following is unsaturated hydrocarbon? Okay, which of the following is actually unsaturated hydrocarbon? So when you see the word unsaturated hydrocarbon, so it has two possibilities. It must be alkene or alkyne. When you see the word unsaturated hydrocarbon, it must be alkene or alkyne, which you can see here. Okay, unsaturated hydrocarbon can be alkene or alkyne. So in this question, so we can see that is the answer. The answer is alkene. The answer is alkene. All right. So remember, unsaturated hydrocarbon is referred to alkene or alkyne. Saturated hydrocarbon is referred to alkane. Yeah, so this question is very straightforward. Okay, so same thing in SPM, we need to know the alkene up to 8 carbon only. So they will only ask you the alkene until 8 carbon. They won't ask you the alkene which has 9 carbon, 10 carbon, 11 carbon, or so on. Yeah, in SPM, the maximum number of carbon they will ask for alkane, for alkene is all until 8. Yeah, they will stop at 8 only. Okay, so you see, if you substitute N equal to 1, you get CH2. Cannot, because I say just now, alkene, the N cannot start from number 1. Cannot start from number 1. Why? Because, you see, it's invalid. Because if you want to have alkene, we must have minimum 2 carbon. Because only we have minimum 2 carbon, then only you got carbon-carbon double bond. So if there is only 1 carbon, you don't have carbon-carbon double bond. So it's not even an alkene. So N equal to 1, it's wrong. Cannot. So this one, I just cut it up. Okay, this one cannot. Okay, so then the N can be 2, 3, 4 until your N equal to 8. Yeah, so if you substitute the N, then this is the formula that you are getting. So remember, all this formula no need to memorize. You don't need to memorize the formula. You can use the general formula to predict. So what is the general formula again? CnH2n. Yeah. So you use CnH2n, then you substitute the number n with the carbon that you want, then you will get your molecular formula. Okay. So this is the quick reminder that I mentioned just now. Alkane, so the N can start from 1. Alkene, the N must start from 2. So this is something that is very important. Okay, so now how the question can be tested. Okay, how they can ask you the question here. Okay, so I'll show you 2 sample question. I'll show you 2 sample question that we can discuss together. Okay, so the first sample question is asking us, what is the molecular formula for the third member in alkene? Okay, so what is the formula for third member in alkene? So to predict the formula for alkene, we use CnH2n. And many students will make a mistake. Many students, when they when they see third member, they will substitute N equal to 3. Then they get C3H6, which is wrong. Okay, which is wrong. Why? Okay, because remember, alkene, the N is starting from number 2. Alkene, in order have carbon-carbon double bond, the N is starting from 2. Okay, the N must starting from 2, then can go for 3, the 4, 5, 6, 7, 8. Okay, like this. So this is the first member of alkene, this is the second member of alkene, and this is the third member of alkene. So you have to be careful. Alkene, the N must starting from 2. So 2 carbon is the first member in alkene. Okay, so now this is the third member. Okay, so this one is the third member of alkene. So now you know already, the third member of alkene, it has 4 carbon. So you substitute N equal to 4 into the formula, then you will get C4H8. Okay, you will get C4H8. So you have to be careful. This question not very hard, but many students make mistakes. So when you should substitute N equal to 3, when the question asks, what is the molecular formula for the alkene which have 3 carbon? If they mention 3 carbon, then you substitute N equal to 3. But they never tell you how many carbon is here. They only tell you it is the third member. So third member. Okay, so please be careful. Third member doesn't mean that it has 3 carbon. Yeah, third member doesn't mean you have 3 carbon, because alkene, the N must start from 2. So 2 carbon is only the first member. Yeah, 3 carbon is the second member, and 4 carbon is the third member. Yeah, so please be very, very careful with this question. Yeah, so next one, you can look at the right hand side now. So this is the sample question number 2. So this is another one question that we will do together. Yeah. So which of the following is the molecular formula of an alkene? Okay, now how to know the substance is an alkene here? So this is a very, very important question. Okay, now let me teach you how to filter the impossible answer first. Okay, we can filter off all the impossible answer. Answer A, C3H7OH. When you see OH, it is alcohol. When you see OH, it is an alcohol. So we are looking for alkene, so it's wrong. So for answer B, C2H5COOH. When you see COOH, okay, when you see the functional group, the sex organ COOH, it is carboxylic acid. Okay, all these we learn in the first lesson. In the first lesson, we learned that, okay, OH is the functional group of alcohol, COOH is the functional group of carboxylic acid. So look at answer C and D. C and D, they only has carbon, they only has hydrogen, so they are hydrocarbon. Yeah, so yes, alkene is an hydrocarbon, because we learned already alkene is unsaturated hydrocarbon. So alkene, it is unsaturated hydrocarbon. And makes sense. Alkene is CnH2n. So alkene only got carbon and hydrogen. Alkene only got carbon and hydrogen. Okay, so this one got carbon and hydrogen. This one got carbon and hydrogen. Okay, so now we must know the answer is C or donkey. So how to know which one is alkene? So a simple tips you can see is this. For alkene, as you can see, CnH2n, N and 2n. So when you see N and 2n means what? The number of hydrogen is always double the carbon. For alkene, carbon and hydrogen always double. You can check back here. 2 and 4 double. 3 and 6 double. 4 and 8 double. Let's say 6 and 12 double. 8 and 16 double. So for alkene, as you can see, the number of carbon and the number of hydrogen is always double. So whenever you're given the formula C, let's say 20H40, when you see carbon and hydrogen, the number double, you know already it is alkene. Yeah, when the number is double up, so it's alkene. So now we are looking for alkene. So the number of carbon and hydrogen must double. So the answer is donkey. As you can see, 5 and 10, the number double up. Okay, the number double up. Okay, so what is the important concept here? You need to understand that alkene, the general formula is CnH2n. So alkene must have carbon and hydrogen only. Alkene must have carbon and hydrogen only. And because this is N and this is 2N, so N and 2N is double. So when you see the number of carbon and hydrogen double up, then you know already that substance is an alkene. Okay, so this is a very fast and simple way for you to know who is alkene. Yeah, all right. So same thing, just like what we learned back in the chapter alkenes. So we have 3 important skills that we need to know. Okay, we need to know 3 important skills for your alkene. We need to know how to draw your alkene. We need to know how to get the name for the alkene, and we must able to get the isomer of alkene as well. Yeah, so in this lesson we will focus on the first 2 skills. In this lesson we will focusing on the drawing and the naming. Yeah, all right. So this concept we learned before in alkane. So if you are very blur, you still very blur, it's highly advisable for you to revise back. Okay, if you are still not very sure, if you're still very blur, so please revise back your alkane first. Okay, because if you don't know how to draw alkane, if you don't know how to name alkane, if you don't know isomer for alkane, there is no way you can do it for alkene, because alkene is slightly more complicated than alkane. I repeat, alkene is slightly more complicated than alkane. If you don't know the alkane, you must revise back first. Okay, then only you continue with your alkene. Okay, let's start. So we will start with the drawing. So how to draw alkene? So this is the strategy to draw alkene. Is actually very similar as how you draw alkane. I repeat, the strategy to draw alkene is very similar to how we draw alkane. Okay, so how to do the strategy? Strategy number 1. So to draw alkene, we must always draw all the carbon atom first. Okay, draw all the carbon atom. Put the carbon atom in a straight line, in horizontal line. Okay, always put the carbon in a straight line like this. Okay, I don't want you to put the carbon like pattern put like this. No one. Okay, so make sure all the carbon just put in a straight line and horizontal line. Okay, just make it easy lah. So after that, you need to connect all the carbon by using single bond. Use single bond to join all the carbon together. Yeah, use single bond to join carbon together. All right. So after that, we need to put in 1 carbon-carbon double bond. Okay, alkene only got 1 carbon-carbon double bond. For SPM, there is only 1 carbon-carbon double bond, because many students do this. See, they do this. Oh, there are 4 carbon. So here they put double bond. Here they put double bond. Here they put double bond. Don't need. So if you have 4 carbon, only 1 double bond is needed. You can put the double bond somewhere here. You can put the double bond at here. You can put a double bond at here. That's it. No problem. Okay, you can put double bond at here, here, or here. But remember, you should only put in 1 double bond. And make sense lah, okay? Right. So as I mentioned before, carbon-carbon double bond is what? The functional group. So functional group, what is the nickname? What is the nickname I give? I call them as sex organ. Common sense, guys. How many sex organ you have? How many sex organ you have? 1. There's only 1 sex organ. You cannot have 2 sex organs, right? You cannot have 3 sex organ. You only have 1 sex organ. So that's why you only draw 1 sex organ, which is carbon-carbon double bond. Okay, in alkene, only put in 1 carbon-carbon double bond. That is good enough already. Yeah? Alright? So after you put in the carbon-carbon double bond, okay, after we put in the sex organ, the next thing we need to make sure every carbon always got 4 bonds. Okay, I mentioned this before. Carbon forever got 4 bonds. Carbon must have 4 bonds. Cannot be more, cannot be less. Carbon must be exactly 4 bonds only. Okay, carbon must be exactly 4 bonds. Then in the end, fill in the blanks with hydrogen. Okay, after we make sure the carbon got 4 bonds, all the empty space you put in hydrogen. Okay, let me use example to show you. Okay, I will use 2 example for demonstration. Okay, let me use 2 example for demonstration. Okay, so the first example is C3H6. As you can see, carbon and hydrogen, the number double. When the number double, now you know already this is alkene. This is alkene. Okay, when you see the number is doubling, you know it's alkene. So always start with drawing the carbon. Okay, as what I say, start with drawing all the carbon. So we have 3 carbon here. So 3 carbon, draw in a straight line. 1, 2, and 3. Okay, draw the carbon in a straight line and join all the carbon together by single bond. Okay, join all the carbon by single bond first. After that, we know this is alkene. Alkene must have 1 sex organ, the double bond. So you can put the double bond. So double bond you can put at here also can. You can put at here also can, up to you. Okay, you can put the double bond at here or here. But make sure only 1 double bond. Don't put 2 double bond. It's wrong. So let's say I put the double bond in at the front. So after that, I need to make sure every carbon must have 4 bond. Every carbon need to have 4 bond. So this carbon got 2 bond already. I add 2 more to make it 4. This carbon you have 1, 2, and 3 bond already. We add 1 more to make it 4. This carbon only got 1 bond. We need to add 3 more to make it 4. Yeah. So after you make sure every carbon got 4 bond, in the end, fill in the blanks with hydrogen. Just fill in the blanks with hydrogen. So now we put in the hydrogen. Okay, so by doing that, you already get the drawing. You already get the structural formula for your alkene. Yeah, so it's very straightforward. Yeah, so we will do the same thing for the next one. So let's move on to example number 2. So for example number 2, we need to draw the structural formula for C5H10. So as you can see, the carbon and hydrogen double up. When the number of carbon and hydrogen double, you know this is alkene. So alkene, we start with drawing the carbon. So we have 5 carbon. So we have 1, 2, 3, 4, 5. 5 carbon. So join all the carbon together by using single bond. So we know this is alkene. So alkene must have double bond. Alkene must have double bond. So you can put the double bond at any place you want. You can put it here. You can put a double bond here. You can put it here. Or you can even put it here. Up to you. So let's say I put the double bond randomly. Okay, I simply I put it here. Okay. So after that, make sure every carbon must have the magic number 4 bond. Carbon must have 4 bond. So I make sure this carbon got 4 bond. This carbon got 4 bond. This carbon got 4 bond. The next carbon must have 4 bond. And the last carbon must have 4 bond. Okay, just make sure every carbon must have 4 bonds. Then we put in hydrogen. Okay, fill in the blanks with hydrogen. Okay, so by doing that, now we have successfully get the structural formula, the drawing. We already get a drawing, the structural formula of alkene. Okay, so this is everything we need to know how to draw your alkene. Yeah. Okay, so we will continue with another skills, which is naming. Okay, how to name the alkene. All right. So same thing, you need to revise back the naming of alkane first. Okay, you must fully understand the naming of alkane before you can continue with the alkene. Okay, so let me show you some strategy, step by step, how to name the alkene first, and then we will do a lot of question together. Yeah, all right. So let's start with this. Okay, so when you come to naming alkene, first of all, okay, you must make sure that the name of the alkene must always ends with "in." The name of alkene must contain the "in" at the back. Yeah, you must have "in" at the back. Yeah. Then you need to find the longest and continuous carbon backbone. Okay, you must always find the longest and continuous carbon backbone. And you need to make sure the longest backbone must contain double bond. So make sure that the double bond is inside the backbone. Okay, so what do I mean? You see, let me show you one example here. Okay, for this question, if you look at the length of carbon, so here you have total 6 carbon. Okay, here this one you have 6 carbon, here you have 6 carbon, and here you have 7 carbon. Okay, so we have 6 carbon and 7 carbon here. Okay, so in this case, many students, they will choose the longest one. They will go for 7 carbon. Okay, they will say, oh, this is the longest one, which is 7 carbon. This is wrong. Why? Although this one has 7 carbon, but you can see that the double bond, the functional group, the carbon-carbon double bond, the sex organ is not inside the longest carbon backbone. Cannot. You must make sure that the longest carbon backbone must contain the sex organ, the carbon-carbon double bond. Okay, the carbon-carbon double bond need to be inside the longest carbon backbone. So in this case, you should choose this one or this one. Okay, these two, although they only have 6 carbon, but the double bond is inside the backbone. Okay, the double bond is inside the backbone. So please, okay, previously back in alkane, we just need to find the longest carbon and that's it. Okay, but when you come to alkene, you have to be very careful. You need to make sure that the longest carbon backbone must contain the double bond. Okay, the longest carbon backbone must contain the carbon-carbon double bond. Okay, so this is something very, very important. Okay, all right. So now let's continue. So after we find the longest and continuous carbon backbone, now for alkene, this is something new for you. Alkene, you need to give the position number for the carbon-carbon double bond. So you need to tell the people where is the double bond. Okay, for alkene, you need to tell people where is the double bond. Okay, right, how to get the position number? You need to count from both ends. You need to count from the left to the right, then you need to count from the right to the left, then you need to choose the smallest number. Here you need to choose the smallest number. Okay, and where you need to put the number for the double bond, you need to put the number before the in. Okay, before the alkene name, before the in. Okay, what do I mean? Okay, let me show you some example. Okay, let me show you some example here. Okay, so we will focus on step 1, step 2, and step 3 first. Step 4 and step 5 is about branch, which we'll cover later. Okay, so let me show you this. Okay, all right. So as you can see, okay, so just like what we learned previously, we have level 1, level 2, and level 3. Level 1, there's no branch. Level 2, we have 1 branch. And level 3, when we have 2 branches. Okay, so we will start with level 1 first. Okay, we will start with level 1. Okay, so for level 1, there are 2 questions here, so which we will do together. We'll do together, level 1. Okay, how are we going to name this compound? So how to name this compound? Remember, when you want to name a carbon compound, you always need to start the name from the back. I repeat, when you want to name a carbon compound, you always want to start the naming from the back. And we know that the back part of the name depends on the functional group. The back part of the name depends on the functional group, the homologous series. Okay, so which homologous series it is? As you can see, there is a carbon-carbon double bond. So when you see a carbon-carbon double bond, you know that this substance is an alkene. And we learned before, if we have alkene, the name must finish with in. The name must end with in. Okay, so let's do it. Okay, let us do it. So this is alkene. So the name must finish with in. So we let the name finish with in. Okay, after that, we need to find the longest and continuous carbon backbone. We need to find the longest and continuous carbon backbone. So in this case, the longest carbon backbone is 4. We have 4 carbon in the longest backbone. So since we have 4 carbon, so 4 carbon is what? 4 carbon is build. Remember, Mama ate papaya, but Papa has hidden orange. So 4 carbon is here. B is build. Okay, build. Alright, so build, butene. B-U-T-E-N-E, butene. Okay, but for alkene you need to specify the location of the double bond. You must tell people where is the double bond. Okay, now I'll show you how to get the location for double bond. Okay, now we need to count from left hand side to the right hand side first. Okay, we will count from 2 directions. So let's try to count from left to the right. So if you count from the left to the right, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. So if you count from the left to the right, you can see that the double bond is on the first and the second carbon. Now you can see the double bond is between the first and the second carbon. Okay, so you need to choose the smaller number between number 1 and 2. Between number 1 and 2, the smaller number is 1. So now you know already the double bond is at location number 1. So where you can put the number, okay, look back to the strategy. You always put the number, okay, always put the number before the in. So you need to do this. So you need to look at the name here. Just look at the name here. So this is the in. Before the in, you need to put a number. So you need to clear a space like this. Open a space. Just open a gap. Okay, so you need to open a gap. So in this gap here, you need to put a number. Okay, here you need to put a number. This number is before the in. Okay, so this number will tell you the location of your double bond. Okay, this number will tell you the location of the double bond. So just now, like what I say, if you count from the left to the right, the double bond is between the first and the second carbon. The smaller number is 1. So it's 1. So you need to put number 1 here. Okay, you need to put the number 1 here. Okay, and remember, between number and alphabet, you need to put a dash. Okay, between the number and alphabet, you need to put a dash. So this is called build 1 in. Okay, this is called build 1 in. Okay, build means what? You have 4 carbon. In means you have double bond. 1 means the double bond is on the first carbon. Yeah, the double bond is on the first carbon. So the number at here will tell you where is the double bond. Okay, now you count again. Okay, now we will try to count again from opposite direction. Now we will go from the right hand side to the left hand side. Now we will count from the right to the left. So if you count from the right to the left, this is carbon number 1, this is carbon number 2, number 3, and number 4. So if you count from the right to the left hand side, now you can see the double bond is between the third and the fourth carbon. Now the double bond is between carbon number 3 and carbon number 4. We always need to choose the smaller number. So number 3 is smaller than number 4. So we will choose number 3. So the name now is called what? Now the name is, you still call it build. You still call it in. Okay, remember when you change the direction, the name is the same. The name is exactly the same. Copy paste. When you change direction, the only thing different is what? The number. Only number will be different. So if you count from the right to the left, the smaller number here is 3. Yeah. So this is called build 3 in. Okay. So I hope you know why we call build 1 in. Why we call build 3 in. So if you count from the left hand side, the double bond is on the first carbon. That's why we call build 1 in. If you count from the right hand side, the double bond is on the third carbon. That's why we call build 3 in. Okay, that's why you revise back the strategy here. Okay, so we need to count from both ends. We need to choose the smaller number, and we need to put the number in front the in, before the in. Yeah, so now remember, in the end, since we have 2 possible names here, we always want to get the smaller number only. Okay, we always want to get the smaller number. So if you compare number 1 and number 3, number 1 is smallest. So this is the final answer. Okay, so this compound is called build 1 in. This compound, the name is called build 1 in. Okay, so I hope everyone understand step by step how I get the naming here. Okay, how the name can be obtained. Yeah, how we get the name. Alright, so now We are done with the first one. So let's try the second one. Let's try the next one. So now we are continue with the next one. Okay, for the next question here. Okay, so now for this question, so you are given the diagram. So same thing, we need to start with the backs. Always start the naming from the back. So to name the back part, we need to know which homologous series it belongs to. Which homologous series it belongs to. So as you can see, there is a carbon double bond. So we can see a carbon double bond here. So this substance is an alkene. So when you see double bond, you know that this is an alkene. So for alkene, we let the name to finish with in. Okay, for alkene, always let the name to ends with in. Okay, so then we need to find the longest and continuous carbon backbone. We need to find the longest and continuous carbon backbone. So which is not 3, because this one can still continue here. So it should be 4. Okay, we have 4 carbon. So when we have 4 carbon is built. 4 carbon is butane. Okay, so remember, you don't let it stick together now, because why? You need to clear a space. You need to make sure that here you have a space. This space is for you to put in the location of the double bond. You need to put a space. This space will let you put the location of the double bond. So what is the location of the double bond here? So we will try to count from both directions. Okay, we will need to count from both directions. So let's count from the left to the right. So if you count from the left to the right, this is carbon number 1, this is carbon number 2, this is number 3, this is number 4. So now as you can see, the double bond is between the second and the third carbon. So between second and third carbon, the smaller number is 2. Okay, so it's called butene. Okay, it's called butene. Now we try to count again from the opposite direction. Now we try to count again from the opposite direction. So now the name copy back. Remember, the name is always the same, even you change the direction. Okay, when you change the direction from the left to the right, from the right to the left, only the number will change. The name is exactly the same. So if you count from the right to the left, this one is the carbon number 1. This is carbon number 1. This is carbon number 2, number 3, number 4. So if you count from the right to the left, the double bond is on the second and the third carbon. Okay, the double bond is between the second and the third carbon. So the smaller number between them is 2. So it's butene as well. So you see, if you count from the left to the right, it's called butene. If you count from the right to the left, it's called butene. So you not even have a smaller number to choose. So what is the name? Butene. Because like what I say, you count from left, you count from right, also called butene. So the name is called butene. So for this compound, we call it as butene. Okay, so I hope everyone know how to do it. Okay, so for alkene, you always need to mention the location for the double bond. Okay, alkene, you need to mention the location for double bond. Okay, but there is a special case. So this is a special case that you need to know. Okay, so let me write it down here. Okay, let me write it down. So for, okay, so I put something here. Okay, for alkene, okay, we need to mention, okay, for alkene, we always need to mention the location of the carbon-carbon double bond. Okay, we need to mention the location of carbon-carbon double bond in the name. Alright. So for example, okay, so you will see the name like this. Okay, like just now the one we have lah. Okay, so you might see the name. Okay, build 1 in. So now you know the double bond is on the first carbon. Pen 2 in. Now you know the double bond is on the second carbon, something like that. Okay, so but there is a special case. So we have 2 special cases. Okay, there are 2 special cases that you have to be careful. Okay, so the 2 special case is this. Okay, for a 2 carbon alkene, 2 carbon alkene is at ethene. Okay, 2 carbon is at ethene. And for a 3 carbon alkene, 3 carbon is prop. 3 carbon is prop, prop. So for 2 carbon and 3 carbon alkene, ethene and also propene, so you no need to mention the location of carbon-carbon double bond. Okay, so for ethene and propene, you don't need to mention the location of the double bond. Okay, for example, you see, okay, you can call this as, okay, so you just need to call it as ethene. Okay, you just call it as ethene. You don't need to call it as one in. Okay, I'll explain why in a short while. Okay, you don't call it as add one in. You don't need to show the number here for ethene. I'll tell you why. So same thing for prop, also same, for prop. Okay, for prop here, P-R-O-P, you just call it as propene. Don't need to mention the number. Okay, just call it as propene will do. You don't need to mention it is prop 1 in. No need to mention. Okay, so why we don't need to mention the number for the ethene and propene? So why no need to mention? Okay, why no need to mention? Okay, why no need to mention here? Okay, is because for ethene and also for propene, okay, for ethene and also propene, there is only one possible name. So you have only one possible name when you come to ethene and propene. So you no need to specify. Okay, you don't need to specify it. Okay, alright, so what do I mean here? Okay, you see, okay, let me show you something like this. Okay, so if you have ethene, 2 carbon, so 2 carbon alkene, when you only can put the double bond here, that you cannot put the double bond here or double bond here already. Okay, when you have 2 carbon, the double bond must be here. So then every carbon you have 4 bond and you put hydrogen. Okay, so if you try to name it, if you try to name this substance, 2 carbon is called at, double bond is called in. So this is the first carbon, this is the second carbon. So the double bond must choose the smaller number 1. So this is at 1 in. So then if you count from opposite direction, you count from the right to the left, this is 1 and 2. So 1 and 2, the smaller number is 1, also called at 1 in. So there is only one possible answer. You only can get at 1 in. Okay, you only get at 1 in. There is no at 2 in at all. Okay, you will never get at 2 in. You will never get at 3 in at all. There is only at 1 in. So since you only have one possible name, you don't need to specify the double bond location. Unlike just now, you see, just now for build we have 2 possible names. Build can be build 1 in or build 2 in. So we have 2 possible names here. So when we have 2 possible names, we need to mention the number. Okay, when we have 2 people, they have 2 possible names, so we need to mention about the number. Okay, we need to mention about the number here, because build can be build 1 or build 2. So we need to specify so that people know we are referring to build 1 or build 2. But at for ethene, forever is number 1 only. You will never get it 2 in, you never get at 3 in. Since there's only one possible answer, no need to mention the number. Just call it ethene. Because when you use the name ethene, we will know already the double bond always at the first carbon. That's it. So you don't need to purposely tell people ethene, the double bond is on the first carbon. You don't need to tell people, because ethene double bond must be at first carbon already. Okay, no other possibility. So no need to purposely tell people. But when you come to build, it's different. Build, you need to tell people build 1 in, so people know the double bond 4 carbon, the double bond is on the first carbon. Build 2 in, so people know that but stands for 4 carbon. The double bond is on the second carbon. So at least you know that, okay, but the double bond can be at the first carbon or the second carbon. There is 2 possibility. When you have more than 1 possibility, you need to mention about the number. Okay, but when you come to it, you only have the double bond forever at carbon number 1. There is no other possibility, so no need to tell people where is the double bond. So same thing goes to propene. So same thing goes to propene. So propene also exactly the same. For prop you have 3 carbon. Okay, so where you can put a double bond, no matter you put the double bond at here or you put the double bond at here, you can check the name is the same. You see, 3 carbon is prop. Alkene, this is in. If you count from the left hand side, this is 1 and 2. The smaller number is 1. Okay, so no number can be smaller than 1 already, right? So if you count from the left hand side, it's called prop 1 in. So now if you put the double bond at here and you do the same thing, 3 carbon is called prop, double bond is called in. You count from the right hand side, this is carbon number 1, number 2 and number 3. So double bond is between the first and second carbon, so the smaller number is 1, so it's prop 1 in. So can you see or not? When you put the double bond at here, is called prop 1 in. When you put the double bond at here, is also called prop 1 in. So the double bond is always on the first carbon. The double bond is always on the first carbon. Of course, the first carbon you can count from the left or the right lah. Like in this case, this one is prop. Okay, this one is prop. The double bond is on the first carbon on the left. This one is also prop 1 in. The double bond is the first carbon on the right. So as you can see, so for propene, okay, the double bond always on the first carbon. Okay, for propene, you will never get prop 2 in. You will never ever get prop 2 in. You will never ever get prop 3 in. Okay, because for prop, the double bond only can be on the first carbon. So since the double bond only can at 1 position, the double bond since only have 1 possible location, no need to mention. Okay, so please read back this one. So why we don't need to mention? Okay, because ethene and propene, there is only 1 possible name. Okay, so add forever get add 1 in, so no need to mention the number. Prop forever get prop 1 in, so no need to mention the number. So this is something very, very important. Okay, this is something very important. Okay, for all the other, then you need to, like but, you need to mention but 1 in, but 2 in. Pen 1 in, pen 2 in. Hex, you need to mention hex 1 in, hex 2 in, hex 3 in. You need to mention. Okay, so but, pen, hex and so on, you need to mention the location for double bond. Okay, but for ethene and propene, you no need to mention. Okay, so this is a special case. Okay, this is a special case that you have to be very careful. Okay, this is a special case that you must be very careful. Okay, so finish. So this is for level 1. So let's move on to level 2. So level 2 is the case that when we have 1 branch. Okay, so what happened when we have 1 branch? Okay, when there is 1 branch, what should we do? Okay, so as what we learned before, the branch can be a non-carbon branch and also it can be a carbon branch. Okay, we learned this concept in alkane already. Yeah, this is the concept that we learned in alkane. So same concept still apply. Same concept still can use for alkene. Okay, so now let us do it. Okay, let us try to do this together. Okay, so how to name it? So now as usual, when you want to name it, always start the naming from the back. So when we see carbon double bond, we know is alkene. So for alkene, we let the name to finish with in. Okay, then we need to find the longest and continuous carbon backbone. Now we need to find the longest and continuous carbon backbone. So we have 4 carbon, so it's called butane. So you don't let them stick together because you need to mention the location of double bond. Okay, you need to tell people where is the double bond. So for the butane, you need to make sure that you create a space. So here must have a spacing. So this is butane. So here you try to put a number later. Okay, we need to put a number for the alkene. Huh? Okay, so now we are done with this. Okay, so in this case, you don't need to go for the number yet. Don't need to put a number now, because as you can see, there is a branch. This chlorine is not inside the backbone. So we learned before, anything not inside the backbone is branch. Anything not inside the backbone, everything not inside the longest backbone is branch. So this chlorine is a branch. So when we have a chlorine branch, we learned before, chlorine branch, we just call it as chloro. Okay, when we have chlorine branch, we just call it as chloro. Okay, so we just call it as chloro. Okay, lastly, don't forget we need to give position number. Yeah, we learned before, whenever there is a branch, we need to give the position number to the branch. Okay, we need to give position number to the branch. Okay, so now you have to be very careful already. Okay, now you have to give the position number to the branch. Okay, so here also have one number. So in this case, you have to be super careful. We need to give number to two people. We need to give the number to the branch, and we need to give the number to the double bond. Okay, so we need to give number to two people, the branch and the double bond. So what you should do here, so please read back the strategy here. Okay, please read back the strategy here. So you must always use the same direction to give the position number to the double bond and the branch. Okay, what do we mean by same direction? Okay, like this. Okay, let me show you how to use the same direction here. Okay, if I want to count from the left to the right, so this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. Okay, so if I go from the left hand side, now you can see the chlorine is on carbon number 2. Okay, the chlorine is on carbon number 2. So I put the number 2 here first, and then I put a dash. And same thing. Now, what about my double bond? Okay, so just now I count my branch from the left hand side. So when I count my double bond, also I need to count from the left hand side. You cannot say, I want to count the branch from the left to the right, but I want to count the double bond from the right to the left. Cannot. You cannot use two direction in one name. You cannot use two direction in one name. Okay, you want to count from the left to the right, everything you count from the left to the right. Okay, this branch you count from the left to the right, this double bond you count from the left to the right. Only use one direction. Okay, only use one direction to count the branch and the double bond. Okay, so please remember this. Only use one direction. So now if I count from the left to the right, the double bond now is between the third and the fourth carbon. Okay, the double bond now is between third and the fourth carbon. So we need to choose the smaller number. Okay, we need to choose the smaller number. So what is the smaller number here? Smaller number here is 3. 3 is smaller than 4. So the number here is supposed to be 3. Okay, so now the name is 2-chloro-but-3-ene. And we are not done yet. Okay, so this is not the final name yet. So what you should do, don't forget, you always need to count from opposite direction as well. Okay, just now I count from left to the right. Now I will count from the right to the left. Okay, now I will count from the right to the left. So if you count from the right to the left, this is the carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4. So when you change the direction, remember, changing direction doesn't change the name. I repeat, changing direction do not change the name. So the name is the same. So the name you can copy paste. Okay, you can copy paste the name. The chloro can copy, the but can copy, the ene can copy. Okay, changing the direction only change the name. Yeah, sorry, changing the direction only change the number. Yeah, change direction only change number, it doesn't change the name. So if you count from the right to the left, now the double bond is between the first and second carbon. Now the double bond is between the first and second carbon. Okay, so we always need to choose the smaller number. Number 1 is smaller than number 2. So the number is 1. Okay, what about the branch? So if you count from the right to the left, the chlorine branch is on the third carbon. The chlorine branch is on the third carbon. So put the number 3 here as the branch. Okay. So now we already get 2 naming. Yeah, we get 2 name already. Okay. So now how to choose the best one? Okay. So we have 2 name. This is the name I get it when I count from the left to the right. This is the name I get if I count it from the right to the left. Okay. So how to get the final naming here? So remember, we learned before, we always want to choose the smaller number. We always want to choose the smaller number. Okay, so you can see 2 and 3. 2 is smaller number. But you see 1 and 3, this is smaller number. So it's very confusing. So if you look at the number in front, this is smaller. But if you look at the number at the back, this is smaller. So what should we do? Okay, so always remember, when we have a number, we always want the smaller number. But now what is the problem? The branch, they want the small number. The double bond also want the small number. Yeah, because now we are giving number to 2 things. We give the number to the branch and we give the number to the double bond. So the double bond want the small number and the branch also want the small number. So we must know who should take the small number. Just like this, okay? These people want to get champion, want to get number 1. This one also want to get champion, number 1. But you cannot let both of them to be champion, right? You need to choose one of them to be champion. Same thing. The branch want a small number. The double bond also want a small number. But you only can give the small number to one of them. Okay, you only can give the small number to one of them. So which one we should give? So look back to the strategy. Okay, look back to strategy. Yeah. The smallest number priority is always given to the double bond. So we want to give the small number to the double bond. So which means that always make sure the number at the back is as small as possible. We want the number at the back to be as small as possible. Why? The number at the back is the number of the double bond. Okay, the number at the back is the location of double bond. Okay, so you see, all right, the branch want the small number, the double bond want the small number. So we should give the small number to the double bond. Okay, we will let the double bond to take the smallest number. Okay, so the double bond number is always at the back. So we always make sure the number at the back as small as possible. So you don't need to worry and don't bother the number at the front. No need to look at it. Okay, don't bother the number at the front. Just look at the number at the back. 1 and 3, 1 is smaller. So now you know already, this is smaller. So this is your final name. That's it. Okay, so this is how we do it. Okay, this is how we do it. Very straightforward. Okay, so we try another one more question here. So for the next question, same thing. We have a carbon-carbon double bond, so it must be an alkene. So this one we have carbon-carbon double bond, so it is an alkene. So then we need to find the longest and continuous carbon backbone. Now we need to find the longest and continuous carbon backbone, which is here. Okay, so this is the longest and continuous carbon backbone, which you have 6 carbon. So 6 carbon is called hexene. So remember, you don't stick together because you need to put a space. So here you need to create a space for you to put the number of alkene. So later you need to tell people where is the alkene at here. Yeah, you need to specify the location of the alkene. Okay, so then we go to check the branch first. Okay, the number we can put later. Okay, so let's check the branch first. So as you can see, there is a bromine. This bromine is not inside the longest backbone. The bromine is not in the longest carbon backbone. So the bromine is the branch. So when we have bromine as the branch, bromine, we call it as bromo. Remember, when we have a bromine branch, we can just call it as bromo. Yeah, we learned this previously. Okay, all right, so we just call it as bromo. And don't forget, we need to give the address. We need to give the position number to the branch. So since we have one branch, we need to put one number in front here. Yeah, and between the number and alphabet, we need to put a dash. Okay, we need to put a dash. All right, so let's do it. Okay, let's do it. So we will try to count from the left to the right. So if you count from the left to the right, so this is 1, okay, first carbon, 1, 2, 3, this is 4 and 5, okay. So you can see the bromine is on the third carbon. The bromine is on the third carbon. So the branch number is 3, okay. And then you can see that the double bond is between the carbon number 4 and carbon number 5. The double bond is between carbon number 4 and carbon number 5. We need to choose the smaller number between these two. 4 and 5, the smaller number is 4. Okay, so 4. So we put the 4 as the location for the double bond. Okay, alright. So don't forget, this is not the final answer. You need to try again in opposite direction. So you need to change the direction from the right to the left. So when you change the direction, the name is still the same. You can copy back the name. Okay, so we still copy back the name. So let us copy back the name first. Okay, alright. So now when we change direction, this is carbon number 1, this is carbon number 2, number 3, and number 4. So now you can see the double bond is between the second and the third carbon. Okay, the double bond now is between second and the third carbon. So the smaller number between them is 2. Okay, so now you need to tell people the double bond is on carbon number 2. Okay, so same thing, the branch, the bromine is on carbon number 4. So the bromine now is on carbon number 4. Okay, alright. So I hope everyone know step by step how am I getting these two names. Okay, how am I getting these two names. Okay, after we get the name, we must know how to choose the proper final answer. Okay, so remember, okay, everyone want a small number. Yeah, the double bond want the small number, the branch also want the small number. Okay, but we always give the smaller number to the double bond. Okay, we always give the smaller number to the double bond, which means what? We always want to get the smallest number at the back. We always want to get the smallest number at the back. So look at the number at the back, 2 versus 4. So 2 versus 4, 2 is smaller. So this is the final name. Yeah, this is the final name. Alright, so it's not very hard, but you have to be very, very careful with the concept. Yeah, it's not hard, but you have to do it carefully, because many students, they know the concept, but they are very careless. There are many students, they can understand the concept, but they are very careless. Okay, so the next thing we need to see, okay, what happens if we have carbon branch. So same thing, we learned about this concept already back in your alkane. So if the branch is carbon, we use the mama eat papaya. Okay, 1 carbon branch, meth, 2 carbon branch, add, 3 carbon branch, prop. So all the carbon branch you must add YL. Okay, 1 carbon branch is called methyl. If the branch got 2 carbon, is called ethyl. If the branch got 3 carbon, is called propyl, and so on. Yeah. So remember, carbon branch, we need to add YL. We need to add YL. Okay. So let us try this. Okay. So we have total 3 questions here, which we will try to do together. Yeah. We have 3 questions, which we will try to do it together. Okay. So let's start with the first one. Okay, we'll start with the first one. So for the first question, as you can see, there is a carbon-carbon double bond. So when you see double bond, you know this is alkene. So when we have alkene, the name, we will let it to end with in. So after that, we find the longest and continuous carbon backbone, which is here, 4. You can choose these 4 or you can choose these 4. It doesn't matter. It's the same. You can choose these 4 carbon or you can choose these 4 carbon. It's okay. So 4 carbon. So 4 carbon is called butane. So same thing, put a space to put in the double bond. Okay, you always need to tell people the location for double bond unless it is propene or ethene. Only propene and ethene, you don't need to mention the number. Yeah, alright. For other alkene, you need to. Okay, so we need to put a space. So we will do the numbering later. We will give the number in a short while. So let's go to find the branch first. So we have a carbon that is not inside the backbone. So this carbon is a branch. This carbon is a branch. So when we have 1 carbon branch, 1 carbon is mama is meth. 1 carbon is meth. Carbon branch add YL. Carbon branch we add YL. So it's called methyl. Okay, we call it as methyl. So remember, Now we already give the name. The name is called methyl already. So the next thing we must able to give the position number to the branch. Okay. So when we have one branch, we need to put one number in front here. Yeah. So here need to put a dash, and here later we put a number. So we have two numbers to put here. We need to put a number for the branch. We need to put a number for the double bond. So same thing, we will count from the left hand side first. So let's count from left hand side. So if you count from left hand side, this is carbon number 1, this is carbon number 2 and 3. Now you can see the double bond is between the second and the third carbon. Now you can see the double bond is between the second carbon and the third carbon. So 2 and 3, the smaller number to choose is 2. Always choose the smaller number 2. So now you know already the double bond is on the second carbon. So same thing. Now what about the branch? What about the branch? So you can see the branch now is attached to the carbon number 3. The branch is sticking to the carbon number 3. So put the number 3 here. Okay, don't forget, you need to try to count from the opposite direction. So when you change the direction from the right to the left, so what should you do? Copy back the name. Yeah. So all the name, just copy back first. Okay, copy back the name. Alright. So now we need to check the number. So if you count from the right hand side, this is carbon number 1, this is carbon number 2, and this is carbon number 3. So as you can see, now the double bond is between second and third carbon. So when the double bond is between the second and third carbon, the smaller number is 2. Okay, so we put the 2 at the back. So same thing, what about the branch? So this is my branch. My branch is on the second carbon. Okay, my branch is on the carbon number 2. That's it. Okay, so now as you can see, we get 2 possible naming already. Yeah, we have 2 names. So always remember, we want to get the smallest number at the back. We always want the number at the back to be as small as possible. But if you look at the number at the back is exactly the same. So when the number at the back is the same, you cannot compare who is big, who is small. Yeah, you cannot compare who has a bigger number, who has a smaller number. So then only you look at the number at the front. So remember, when you given 2 names, you always focus on the number at the back first. Okay, if you can see the number at the back, who has a smaller number, that is the final name already. Only when the number at the back is the same. When the number at the back is the same, no choice. No choice. Then we have to look at the number at the front. So look at the number at the front. Who is smaller? 2 is smaller than 3. Okay, so then we know already your final answer should be this one. 2-methyl butane. Okay, the final name is 2-methyl butane. Okay, all right. So what about the next one? Okay, so let's try another one more. Okay, so this is another question that we can try. So same thing, we need to start with the back part of the name. So we can see there is a carbon-carbon double bond. So when there is a carbon-carbon double bond, it is an alkene. So we let the name to ends with "ene." Okay. So then we need to find the longest and continuous carbon backbone. So the longest carbon, make sure it contain the double bond. Okay. So you see, this one got 4 carbon. This one you got 5 carbon. Okay. Alright. And this one got 4 carbon. So the longest one is here. This one you have 5 carbon and you have double bond inside. Alright. So this 5 carbon is your longest backbone. So 5 carbon is called pentene. 5 carbon is pentene. So same thing, we don't stick it together now. We need to put a space to put the location of double bond. Okay. So then you can see outside the backbone there is a carbon. So this carbon is a branch. So we have one branch here. Okay, we have one branch. So when we have one carbon branch, is called methyl. Remember, carbon branch at YL, methyl. So then we need to give the position number to the branch. Okay, so now let us give the position number to the branch and the position number to the double bond. Okay, so we will count from the left hand side. So left hand side, this is carbon number 1, this is carbon number 2, this is carbon number 3 and number 4. So as you can see, the double bond is between carbon number 3 and carbon number 4. So since the double bond is between carbon number 3 and carbon number 4, we need to choose the smaller number. The smaller number is 3. So this is pen 3 in. So this is pen 3 in. Okay. So what about the branch? So as you can see, the branch is on the carbon number 3. The branch is sticking to carbon number 3. So the branch, the number is 3. Okay. So now we will try to count again from opposite direction. So if you count from opposite direction, which is from the right to the left, so this will be your first carbon. So this is carbon number 1, this is carbon number 2, this is carbon number 3. So if you go from opposite direction, you can see that now the double bond is between the second and the third carbon. Now the double bond is between the second carbon and the third carbon. So the smaller number is 2. Choose the smaller number. So small number is 2. So put the number 2 at the back. Okay. So what about the branch? So the branch now is sticking to carbon number 3. So the branch is sticking to carbon number 3. So the branch number is 3. Okay. So then we copy the name. Just copy paste the name. So now copy back the name methyl. Copy back the name pen. Copy back the name in. Okay. So now we get 2 names. So same thing, make sure you know how to choose the most suitable one. Which one is the best answer? So we always want to get smaller number, and the smaller number we always focus at the back. We always want the number at the back to be as small as possible. So just look at the number at the back. So which one has a smaller number? This one has a smaller number. So now we know already the name is this 3-methyl pen 2-in. Okay, so the name is 3-methyl pen 2-in. Okay, so just do it carefully. You just do it step by step, then you will get the answer already. Okay, so let's try one more question. Let's try one more question together. So this question, same thing. I want to name it. Okay, I want to get the name of this substance. So to start the naming, I want to start the name from the back. So to know the name at the back, I need to check the functional group, the homologous series. So I can see carbon-carbon double bond as the sex organ. So when you have carbon-carbon double bond as the sex organ, it is alkene. So alkene, the name must end with in. So for alkene, we let the name to finish with in. Then we need to find the longest and continuous carbon backbone. So many students, they will choose this one. Okay, many students, you see, you have to be careful. They will choose this one here, which is not. Why? Because if you look at this one, alright, is 1, 2, 3, 4, 5, 6, is only 6 carbon. And more importantly, the double bond is not inside the backbone. You see, single bond, okay, single bond, okay, single bond and single bond. Cannot. When you have alkene, you must make sure the longest backbone is inside. The longest backbone contain double bond. Okay, the longest backbone must have double bond. So your longest backbone, suppose the longest backbone in this question, okay, supposed to be here. Okay, alright, so sorry, erase it. Okay, so in this question, the longest backbone supposed to be here. Okay, which you have 7 carbon. Okay, you should have 7 carbon in this. So 7 carbon is called hep. 7 carbon, we call it heptene. Same thing, we put a space for the location of your double bond. Okay, so then we need to check, is there any branch? So these 2 carbon, they are not inside the backbone. So these 2 carbon, they are branch. Okay, so this is 1 branch, not 2 branches, because you can see on the backbone here, this is the branch, and this branch, the 2 carbons sticking together. So this is only 1 branch. Okay, so we have 1 branch, and the branch has 2 carbons. So 2 carbon is what? So okay, 1 carbon is meth, 2 carbon is et. Okay, mama it, it is ETH. So 2 carbon is ETH. And remember, for all the carbon branch, you need to add YL, ethyl. Okay, you need to add YL, ethyl. And don't forget to give the position number to the branch. So you need to put a number for the branch, and between the number and alphabet, you need to put a dash. Okay, so now let us count from both ends. We count from left to the right and right to the left. So if I count from the left to the right, so this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5. Okay, so if you count from the right to the left, okay, sorry, left to the right, the double bond now is between the 4th and the 5th carbon. So the smaller number is 4. 4 is the smaller number, which is the location of your double bond. Okay, so what about the location for your branch? So as you can see, this is the branch. The branch is on carbon number 4 as well. Okay, so it's 4 lah. So don't forget, we need to try to count again from the opposite direction. So if you go from opposite direction, okay, you can copy back the name. Okay, just copy back the name first. Okay, so now I will copy back all the name, and then I will start to count again from the opposite direction. Okay, so now I will start to count from right to the left. So now I will start to count from the right to the left. So this is carbon number 1, carbon number 2, this is carbon number 3, number 4. So now as you can see, the double bond is between carbon number 3 and carbon number 4. Now the double bond is between carbon number 3 and carbon number 4. So we need to choose the smaller number. So the smaller number is 3. So we need to choose number 3. So put number 3 at the back, which is the location of your double bond. So then we need to tell people the location of your branch. We need to mention where is the branch. So as you can see, the branch is sticking to the carbon number 4. Yeah, so the branch is sticking to the carbon number 4. So we put number 4 at the front. Okay, that's it. So now we are all done. So same thing, now we need to choose the best answer. So how to choose the best answer? We always want the number at the back to be as small as possible. Okay, we always want the number at the back to be as small as possible. So number 3 is smaller than number 4. So now we will choose this one as the final answer. Okay, so I hope everyone can understand how I do the naming. This is the level 2 of naming. So it's not hard. You just need to do it step by step. Just do it step by step and do it carefully. Yeah, do it step by step and do it carefully. Then you will be able to get the name already. Okay, so now we move on to the last one, which is level 3. Okay, level 3. So level 3 is the case of 2 branches. Okay, what if we have 2 branches? So we will use exactly the same concept that we learned in alkene. In alkene, we learned it before already. So if we have 2 branches, we use the magic word called di. 2 branches called di. Okay, 3 branches is called tri, but it's not in your syllabus. Okay, so if you have 2 branches, we use the word di. 3 branches use the word tri, but 3 branches is not in your SPM syllabus. Yeah, so just focus on 2 branches will do lah. Okay, so 2 branches use the word di, and then when we have 2 branches, you always need to give 2 position number. You need to give 2 address. Yeah, 1 branch, 1 position number. 2 branches, 2 position number. 3 branches, 3 position number. So that is quite simple lah. Yeah. So we will have 2 questions here. Okay, we have 2 questions to discuss together. Yeah, we have 2 questions to discuss together for the naming lah. Okay, so let's do it. So as you can see, this question you have a double bond. So it's alkene. So we let the name to finish with in. So we go to find the longest carbon backbone, which is here. So the longest carbon backbone, you have 5. So 5 is called pentene. So put a space here for the location of double bond later. So as you can see, outside the backbone, you have bromine and bromine. So these 2 bromine, they are the branches. So we have 2 bromine, we have 2 branches. So when we have 2 branches, use the word di, di. When the branch is made of bromine, we just call it as bromo. Yeah, when the branch is bromine, so we just name it as bromo. Yeah, so it's di-bromo. So when we have 2 branches, we need to give 2 number in front. So in front here, need to put 2 numbers. Okay, and then you need to put a dash here lah. Okay, so now let us do it. So let's count from the left hand side to the right hand side. So if you count from the left to the right hand side, this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. So as you can see, one of the bromine is on carbon number 2, another bromine is on carbon number 3. So now we know already the location for the branch, which is on carbon number 2 and carbon number 3. And when you have two numbers, remember in between them you need to put a comma. You need to put a comma. Alright. So now we need to get the number for the double bond. So as you can see now, the double bond is on the carbon number 4 and carbon number 5. So the smaller number is 4. Okay, the smaller number is 4. Okay, so now we get the name already. So then now we count again in opposite direction. So now we try to count from opposite direction. So when you count from opposite direction, you're not starting here number 1 because this is not the last carbon. This is the terminal. Terminal means the first or the last carbon. Always count from the first or the last carbon. So this is carbon number 1, carbon number 2, carbon number 3, carbon number 4, and so on. So as you can see, now the branch is on carbon number 4 and the branch is on carbon number 5. Okay, so the branch is on carbon number 4 and the carbon number 5. So if you have two numbers, just put a comma. Yeah. So the name you can copy back. This is di, this is bromo, and this is pen, and this is in. Okay. So now we need to give the number to here. This is the number for the double bond, the location of double bond. So where is the double bond? The double bond is between the second and the third carbon. So when the double bond is between the second and the third carbon, choose the smaller number, which is number 2. So choose the number 2 here. Okay. So now we already get two possible naming. So how to choose the best answer? Okay, how are we going to choose the best answer in between these two? So we always want the smaller number at the back. We always want the smaller number to be given to the double bond. We always want the small number to be given to the double bond, which is the number at the back. So the number at the back need to be as small as possible. 2 is smaller. Yeah, so 2 is smaller. So now we know this is the final answer. Yeah, all right. So let us move on to the last question. Okay, so this is the last question for the naming. Okay, so this is the last question for the naming. So let us do it together. So we have double bond here. So it is an alkene. So we let the name to finish off with in. Okay, we let the name to ends with in. So then we need to find the longest and continuous carbon backbone, which is here. So the longest backbone have 5. So 5 carbon is called pen. So this is pentene. Okay, all right. So put a space for the double bond. So as you can see, this carbon is not in the backbone. This carbon is not in the backbone. So we have two branches. So when we have two branches, use the magic word di. Okay, use the magic word di. And do remember, these two branches, they are separated. So one branch is on top, one branch is at the bottom. So they are not the same. So when these two branches, they are separated, you cannot total up the carbon. You cannot say, here got one carbon, here got one carbon, two carbon add together. So two carbon is add. So called ethyl. Cannot. Okay. So these two branches, they are not sticking together. So you cannot total up. You only can total up like this. Okay. Let's say this is the backbone. And here you have a branch. And this branch got 1 and 2. You see, this branch got 2 carbons sticking together. Then only you can call it as ethyl. But now what happened is that you have two branches. One branch is here. One branch is here. So these two branches, they are separated. So you cannot total up. Okay, you cannot total up. So how to name it? So you have to name it separately. So when these two branches separate, you have to name it separately. So this one, you have one carbon. One carbon is meth. Carbon branch at YL, methyl. So this branch also one carbon, methyl. So when we have methyl branch, when we have two of it, okay, when the methyl branch, we have two of it. So how to call it? You can just call it as dimethyl. Di means you have two methyl branch. So we have two methyl branch. Okay, so just call it as dimethyl. Okay, just call it as dimethyl. Okay, so let us finish it. Let's finish it. Okay, so now we already named the branch. So now we just move on to the last thing. So the last thing we need to know is how to give the location, the position number to the branch. Since we have two branches, we need to put two number here. Okay, so the number and the alphabet need to put a dash. Don't forget to put the dash. Okay, all right. So now let's count from the both side. So we count from the left hand side. So left hand side, this is carbon number 1, this is carbon number 2, this is carbon number 3 and number 4. Now you can see both of the branch is on carbon number 2. So this branch is on carbon number 2, this branch also on carbon number 2. So the number is 2 and 2 lah. So the number need to put comma, yeah. So what about the number at the back? The number at the back is the double bond. So double bond is on the third and the fourth carbon. So choose the smaller number, 3 and 4. The smaller number we choose 3. Okay, we choose 3. Okay, so that's it. So don't forget we need to try to count again from opposite direction. So let's count again from opposite direction. So now we can copy back the name. Just copy back the whole naming first. Okay, then only you count from the opposite direction. So now we will count from the right to the left. So this is carbon number 1, number 2, number 3, number 4 and number 5. So as you can see, now the double bond is between the second and the third carbon. Okay, now the double bond is between the second and third carbon. Choose a smaller number, 2. Okay, what about the branch? So now the branch, both of the branch is on carbon number 4. Okay, both of the branch is on carbon number 4. So we write 4, 4. Okay, so now we get two possible name already. So in the end, make sure you always choose the smaller number at the back. So look at the number at the back. 2 is smaller than 3. So now we know which one to choose. Okay, so now we already know which one you should choose. Okay, so I hope all these examples give you a better idea how to name your alkene. Actually, the concept of naming alkene is very similar like naming alkane. The only difference now is that you need to mention the location of double bond. You need to mention the location of double bond. And you only choose one direction to count the location for branch and double bond. Okay, remember, if you want to count the branch from the left, you must count the double bond from the left also. If you want to count the branch from the right hand side, you must count the double bond from the right hand side. Only use one direction. And always remember, who will get the smaller number? The double bond. The double bond will get the smaller number. So you always want the number at the back to be as small as possible. Yeah? Alright, so this is everything you need to know. Okay, so now the last thing that we need to learn for today's lesson is this. Okay, so just now we are given the diagram. Just now we are given the drawing, and we change the drawing to the name. Just now we learned how to change drawing to the name, but we also need to know the other way around. We must know how to change the name to the drawing. So if they give us a name, you must know how to draw. Okay, if you are given a name, you must know how to draw. Okay, all right. So you see, so if the name is given, how to draw the structural formula. Okay, how to draw when the name is given. So let's look at the strategy. So I'll show you the strategy first. Then we will do 3 questions here. Okay, there are total 3 examples we will do together to finish with today's lesson. Okay, so step number 1, always start to draw from the back. Okay, so start from the back to know what is the functional group. Okay, start from the back to know what is the functional group. For example, you see pen to in, start from the back, in. So in means it's alkene. So when this is alkene, you know you have carbon double bond. Okay, that's it. So the next thing, Then you need to go to draw the, okay, the next thing now, you need to draw the longest and continuous carbon backbone. Okay, you need to draw the longest and continuous carbon backbone. So how to draw the longest and continuous carbon backbone? Refer to the name, the prefix before the last number. Okay, look at the last number. So this is the last number. Before the last number, this one is the longest carbon. So when you see the word pen, pen means what? You have longest 5 carbon. So let's draw it. Okay, so we draw longest 5 carbon. So 1, 2, 3, 4, 5 carbon. And all the carbon need to link together first. Okay, so we need to link the carbon together. Okay, so then we need to put the double bond to the right location. Okay, put the double bond to the right location by referring to the number at the back. So look at the number at the back, so we will know where is the double bond. So you see, so what is the number at the back here? 2. So number 2 here means what? The carbon double bond is on the second carbon. Okay, when you see 2 at the back means what? The double bond is on the second carbon. So now you can decide yourself. You want to count from the left also can. You want to count from the right also can. Let's say if you count from the left, this is the second carbon. So you put the double bond on the second carbon like this. Or you also can count the other way around. Okay, you also can go the other way around. Okay, so you also can count like this. Okay, you also can do this. Okay, let me find it out first. Alright. Okay. Or you also can count from right to the left. If you count from the right to the left, this is carbon number 1, this is carbon number 2. So on carbon number 2, there is a double bond. That's it. Okay? So up to you. You want to count from left also can, right also can. No problem. Up to you. So let's say I count from the left. This is carbon number 2. This is where I got my double bond. Okay? This is where I got my double bond. Okay? So settle. Alright. So after you draw all the things like this, okay? After you draw all the things like this, okay? So then you have to check the next one. Okay? Let's see the next one. So the next one, you have to look at the front number to determine the number of branch. Okay, so do we have branch here? So in this case, do we have branch? Okay, how to know we have branch or not? Look at in front here. So if right in front you see nothing, means no branch lah. If you have branch, you can see. Okay, if in front here got one number, means one branch. If right in front here you see 2 numbers, which means that you have 2 branches. Okay, by looking at the numbers in front, you know whether you have branch or not. Okay, so in this case, I know I have no branch at all. So in this case, I don't have any branch. Okay, so what is the next thing I do? So now you need to make sure each carbon always got 4 bond. Okay, make sure every carbon got 4 bond and fill in hydrogen. Okay, make sure the carbon got 4 bond and put in your hydrogen. Okay, so let's do it. So this carbon got 1 bond, you put in 3 more. This carbon, you have 3 bonds already, you put 1 more. So the 1 bond you want to put on top also can, you want to put at the bottom also can, up to you. Okay, so up to you. Okay, so then after the carbon got 4 bond, then you put in your hydrogen. Okay, so this is step by step how you change the name into a structural formula. Okay, this is how we change the name to become a drawing. Okay, so let's do the same thing. So we have 2 more examples. So let us finish it. Okay, let us finish off the last 2 examples together. Okay, all right. So now same thing, 3 bromo hex 1 in. So always start with the back. So when you see in means alkene, you have carbon double bond. So then we need to check the longest carbon. So the longest carbon is before the number. So this is hex. So hex means what? The longest carbon got 6. So we have longest 6 carbon. So let's draw it up. Okay, let's draw it up. Longest, we have 6 carbon. So then we need to check is there any branch or not. Okay, after draw the longest one, sorry, before we go to draw the branch, after draw the longest carbon backbone, you need to put in the double bond. You need to put in the double bond. So where is the double bond? Look at the number here. The number is 1. So the number is 1 means what? The double bond is on the first carbon. Okay, the double bond is on the first carbon. So where is the first carbon? Up to you. You can count from the left. This is the first carbon. You put a double bond here. Or you can count from the right. This is the first carbon. You put the double bond here. Up to you. Okay. So let's say I count from the right hand side lah for this question. Okay. Let's say I count from right hand side for this question. So I put my double bond at here. Okay. I put my double bond at here. Alright. So now the next thing I need to check, is there any branch or not? Is there any branch or not? Okay. Alright. So how to know whether we have any branch or not? So look at the front number. So right in front here we see there is 1 digit. Okay, when you see 1 digit means you have 1 branch. So when we have 1 branch, the next thing you must know, where is the branch? So the branch is on carbon number 3. So carbon number 3. So you have to be careful. You cannot count here 1, 2, 3. Carbon number 3 cannot. Why? Just now when you put the double bond, you count from the right hand side. Okay, just now I count from the right hand side. So if I count from right hand side for the double bond, now the branch also need to count from right hand side. Okay, remember, only use one same direction. Use the same direction to count the double bond and the branch. You want to count the branch from the you want to count the double bond from the left, then you count the branch from the left also. You want to count the double bond from the right, which is what we are doing now, then you must count the branch from the right also. So you count from the right. So this is carbon number 1, number 2, and number 3. So you know this is the location of the branch. Okay. So after you know the location of the branch, so you must draw it up. Okay. So you know the branch is here. So up to you. You want to put the branch on the top, or you want to put the branch at the bottom also can. Up to you. You can draw the branch on top or bottom. Up to you. So let's say I draw at the bottom. So what is my branch? So my branch is a bromo. Bromo means what? Bromine. My branch is a bromine. Br. So after you finish everything, you see, we finish everything already. Number 3, settle. Bromo, settle. Hex, settle. 1, settle. In, settle. So everything is done. So now after we finish with everything, so don't forget, now you need to put in your hydrogen. Okay. So how to get the hydrogen? Always make sure carbon got 4 bonds. Okay. Always make sure carbon contain 4 bonds. Okay. Then you put in your hydrogen. Okay. So that's it. Alright. So this is how are we going to get it. Okay. This is how are we going to get the diagram. Okay. So let us finish off with the last part. So the last example for today's lesson is this. 3,4-dimethyl heptene. 3,4-dimethyl heptene. So same thing, always start from the back. Always start from the back. So we have in. So in, which means that is alkene. Alkene must have double bond. Then when we see the word hep means what? The longest carbon got 7. So we will draw 7 carbon. Okay, let us draw 7 carbon first. 1, 2, 3, 4 and 5, 6 and 7. Okay, we will draw 7 carbon. So after that, you need to put the double bond to the right location. So as you can see, the number is 2. Number is 2 means what? The double bond is on the second carbon. The double bond is on the second carbon. So now you need to decide. You want to count from the left or you want to count from the right? Up to you. So you need to decide. You want to count from the left or you want to count from the right? So let's say I count from the left. So if I count from the left, this is the second carbon. So this is where I got my double bond. Okay. Alright, next one. I need to check whether there is any branches or not. So as I can see, there are 2 digits in front here. So which means I got 2 branches. So I got 2 branches. So where is the branch? Carbon number 3 and carbon number 4. So let's count. So carbon number 3, 1, 2, 3. So carbon number 3, there is a branch. So you want to put the branch on top also can. You want to put the branch at the bottom also can. Up to you. So let's say we draw it at the bottom. So let's say on carbon number 4, there's also a branch. On carbon number 4, there's also a branch. So this is carbon number 4. you have another branch. So same thing, you can put a branch on top or you can put a branch at the bottom, up to you. So let's say I draw it on top. Okay, it's up to you. Draw on top also can, draw at the bottom also can. Yeah. So now I already put in the number here. So the next thing, so I need to put in my branch. So what is my branch? Dimethyl. So the word di means I got 2 branches only, which is yes, I got 2 branches. So what is the branch? My branch is methyl. The word meth. Meth means what? Meth means 1 carbon. Okay. So meth means 1 carbon. So my branch got 1 carbon. So this branch got 1 carbon. So this branch got 1 carbon. That's it. Okay. So now we finish everything already. So now we just need to put in the last thing, the hydrogen. Okay. So to put the hydrogen, we need to make sure every carbon must have 4 bonds. Okay. So top up and make sure every carbon contain 4 bonds. And after every carbon contain 4 bonds, you can put in your hydrogen. Okay, just put in the hydrogen into your diagram, into the structural formula. Okay, so do it slowly, do it carefully. Yeah, just do it slowly, just do it carefully. Don't be careless. Okay, so by doing that, now we already convert the name to become the structural formula. Okay, so this is everything that we are learning today. Yeah, so today we are learning 2 important skills. Okay, today we are learning this. Okay, today we start with a new subtopic called alkene. So today we start with a new subtopic called alkene. So we learn about the functional group, we learn about general formula. Okay, and please remember, alkene, the end must start from 2. Alkene, the end is starting from 2. Okay, and then we also know that alkene is unsaturated hydrocarbon. So when they use the word unsaturated hydrocarbon, is referred to alkene or even alkyne. Alkene and alkyne, they have double bond and triple bond. So when you have more than single bond, you are unsaturated. So when you see unsaturated, is alkene or alkyne. Saturated is alkene. This one is so important, yeah? And make sure you know that, okay? Make sure you know 3 important skills. Today we learn 2 of it. Today we learn how to draw the alkene, and today we learn how to name the alkene. Okay, so this is everything that we are learning in this lesson. So in the next lesson, we will learn about the isomer. Okay, in the next lesson, then we will learn step by step how to get the isomers for alkene. Alright, so I hope everyone understand the concept. I hope everyone understand the concept. You know exactly how it works. Okay, so in the next video, before we learn the isomers of alkene, I will have a self test. Okay, so there will be a self test. So I will give you some question for the naming of alkene. Okay, you need to try to do it. You can try to do the question for naming of alkene. Yeah, so I think that's it. Okay, so this is everything that we are learning for this particular video lesson. Yeah.